On an end-to-end network, protection needs to be provided for service access devices and OTN devices on transport networks, ensuring high network reliability and improving device disaster recovery ability. Protection provided by transitional OTN devices is layered 0 or layered 1 protection, and packet service protection provided by MS OTN devices is layer 2 protection. In this video, I will describe the various types of packet service protection provided by MS OTN devices. Packet network level protection mainly has two protection modes, namely 1-to-1 protection and 1+1 protection. 1+1 protection. At the source end, services are duly fed to the working channel and protection channel. At the sink end, services are selectively received from the working channel. If the working channel becomes faulty, services are received from the protection channel at the sink end. 1-to-1 protection. In normal situations, services are transmitted only on the working channel. If the working channel becomes faulty, services are switched to the protection channel. Since no services are carried on the 1-to-1 protection channel in normal situations, the protection channel can be used to transmit other services with low reliability to improve bandwidth utilization. The 1+1 protection and 1-to-1 protection switching modes are similar. The following uses 1+1 protection as an example to describe them. Since services are bidirectional, the switching can be implemented in one or both directions. If switching is implemented in only one direction, we call it unidirectional switching. If switching is implemented in both directions, we call it bidirectional switching. After switching, if a fault on the working channel is fixed, you can select the non-revertive or revertive mode to determine whether to restore the working channel as the service receiving channel. In non-revertive mode, services are still received from the protection channel even after a fault on the working channel is resolved. In a revertive mode, services are received from the working channel after a fault on the working channel is resolved. Huawei MS OTN devices provide comprehensive network-level protection schemes to meet service transmission reliability requirements at the packet layer. In a link aggregation group flag, multiple Ethernet interfaces are bound into a logical interface to increase link bandwidth and improve link reliability. A lag group can work in load sharing or non-load sharing mode. In load sharing mode, each member in the lag group carries traffic and shares the load. In load sharing mode, each member in the lag group carries traffic and shares the load. In non-load sharing mode, one member link in the lag group functions as the active link, and the other member link does not carry traffic and is in a standby state. If the active link fails, the standby link takes over. A multi-chassis link aggregation group, MCLAG, allows multiple devices' data links to be aggregated to form a lag. If a link fails, services are automatically switched to other links in the MCLAG group, enhancing link reliability. MCLAG mainly applies to dual homing scenarios after protection switching to enable services to be transmitted. On the network side, MCLAG needs to be used together with other types of network protection such as ERPS, NCPWAPS, and PWFPS, LPT, namely Link State Path Through. On a traditional network, protection is mainly provided for services when faults are found on a service access point or on an intermediate service network. However, user services cannot be protected if faults are found on both the service access point and intermediate service network. The LPT function can be enabled to proactively detect and report service access point faults and intermediate service network faults. If a fault occurs, the user access devices at both ends of a service network are notified to use the backup network for communication ensuring normal transmission of important data. Tunnel APS provides protection for tunnels based on the APS protocol. For PWAPS and Tunnel APS, the protection principles are similar, but the protection granularities are different. To be specific, PWAPS provides protection for PWS, while Tunnel APS provides protection for tunnels. If the working tunnel or PW becomes faulty, services can be switched to the specified protection tunnel or PW so that important services are protected. Multi-chassis pseudo-wear automatic protection switching MCPWAPS supports configuration of the working and protection PWS on different devices to implement cross-device PW protection. MCPWAPS applies to dual homing service scenarios. MCPWAPS works together with MCLAG to form a complete inter-device protection scheme. Ethernet ring protection switching (ERPS) provides Ethernet ring protection for eLAN services on Ethernet rings based on the APS protocol. After ERPS is configured on a ring network, the port between PE1 and PE4 is blocked in normal situations so that services can be transmitted only through the port on the other side, preventing service loops. If a link or NE on the ring network is faulty, the port between PE1 and PE4 is unblocked so that services cannot be transmitted over the faulty link or NE, achieving ring network protection. MPLS-TP ring protection switching (MRPS) protects packet services on a ring network. It mainly applies to networks with many ring networking scenarios. If the working channel between CES, Node B, and RNC is faulty, the reverse protection channel on a ring network provides protection for the services. No matter which type of protection is used, packet network level protection aims to quickly restore services and ensure reliable service transmission. Protection needs to be configured based on network situations to ensure timely service restoration and prevent long-term service interruption.